pieces of this are easy and pieces of this are hard, so just kind of bear with me. When we're looking at a graph, it says f of x is increasing if and only if, all values of f of a are less than f of b. So like say here's a, here's b, that f of a is always less than f of b. So this kind of is, sometimes mathematicians get a little bit funky here. To me, just by looking at your picture, you can tell this is going up and this is going down. Okay? We just say f is decreasing from negative infinity to 0. And we include with decreasing and increasing. F is increasing from 0 to infinity. So we're going to get a whole lot better at interval notation in this section because that's how we state where it's increasing and decreasing. So if you're just looking at the F graph, you're just saying, where does it go down? Where does it go up? So go ahead and try. Find the intervals where F is increasing and where it's decreasing. Now, the big thing that I want you to notice, where does it quit increasing or decreasing? Notice that it goes up, then there's a 0 slope, down, 0 slope, up. So where it begins and ends will be at your 0 slopes. That's going to be important when we're looking at equations and not the graph. All right. So it's increasing, and this is going to be important because sometimes you might look at the derivative graph and you look for different things. This is the graph of f. So where is it going up? Since there's an arrow, we start at negative infinity. We only look at the x coordinates to -1, including -1, union, when does it start going back up again? At 2 to infinity. Where is it decreasing? We go, and this just kind of fills in what we didn't do. From -1 to 2, it's decreasing. So just getting used to the notation and how to think of it will be one of the critical things in this section. All right, so does it also make sense that f is increasing if the derivative is greater than 0, which is positive? If there's a positive slope, positive gradient, that means it's going up. If there's a negative gradient, negative slope, it's going down. So this is what we're really going to get into now because we're going to use this for our equations. So let's look at some examples. So in x squared, we see it's going down here. We already kind of did this one, didn't we? And look at, this is what I really want us to look at. We're going to use sign charts to help us. On the sign charts, we're going to put two things. Either where the derivative is 0 or where the derivative does not exist. So when is it equal to 0 or it doesn't exist if it makes the denominator 0. So we'll get into that. So we can see that f prime is negative on left of 0. See how we put in 0 because that's where our 0 slope is. So f is decreasing. F is increasing on the right side of 0 because the slope is positive. Okay. How about here? So we can see a 0 slope at 0. So notice they also give us the derivative. So let's look at the equation this time. So where does the derivative, we always want to find where does the derivative equal 0. So when does negative 2x equal 0? When x equals 0. So this is the algebra part. This is the graph part. It kind of all goes together. So whenever we get this, this is what goes on the sign chart. And if I plug in a number to the left of 0, like negative 1, if x is negative 1, negative 2 times negative 1 is a positive value. When f prime is positive, f is increasing. Then we would pick a number to the right of 0, positive 1. Negative 2 times positive 1 is a negative number, so then f is decreasing. So this shows the graph, and this is the algebra. So sometimes it just depends on what you're looking at. Okay, so notice here, there's a 0 slope here. So we do put 0 here. So think of when does 3x squared equal 0 is when x equals 0. But notice this is always going up. F prime is always positive. And look at the derivative. It doesn't matter what number I plug in for x, I'm always going to get a positive value. So if it's always positive, that means it's always increasing. And it's never decreasing. Okay, this last one will probably be the best example. So we have f of x equals x to the third minus 3x plus 4. So we look at the derivative, which isn't too hard. Then you've got to be able to factor to do this next part. GCF, factor out the 3. Then we have the difference of two squares, x plus 1, x minus 1. So when does f prime equal 0? If we set the derivative equal to 0, this equals 0 when x is negative 1. This equals 0 when x is positive 1. So I include negative 1 and positive 1 on my number line. So if I pick a number like negative 2, that would be to the left of negative 1, and I plug it in, I would get 3 times negative 1 times negative 3. I don't even care what the number is. That ends up being a positive number. So since f prime is positive, f is increasing. So we're just going to choose numbers in each interval to figure this out. So let's look at a couple problems. All right, so this one we just are using the equation. That's normally how it is. So you can't just rely on the graph. So in order to find where something is increasing or decreasing, we have to look at the derivative. What is the derivative? Negative 3x squared plus 6x. Then we set it equal to 0. GCF. I'm going to pull that negative out with the 3 and the x, because 3 goes into both 3 and 6. They both have an x. It just makes the factoring or the zeros easier, I think. So divide negative 3x squared by negative 3x. We get x. 6x divided by negative 3x, negative 2. Okay, so what makes negative 3x equal 0? When x equals 0. What makes x minus 2 equal 0? So these are the two values I'm going to put on my number line. 0. And since it's a number line, you have to go in order. All right, so now we have to do the work here. So what would be a number to the left of 0? Let's choose -1. We're just going to substitute it in for this x and this x and figure out, is it a positive or negative number? So -3 times -1 is 3. -1 minus 2 is -3. So this side is negative. In between 0 and 2, the best number to pick is 1. Oh, and you can write f prime is negative, so f is decreasing. Now let's plug in 1 back in for our x. We get -3 times -1. A negative times a negative is positive. Now f is increasing. Now I'm going to pick 3. -3 times 3 is -9 times 1 is negative. So it's decreasing. Now let's think about the degree and the shape here. -x to the third, I would expect to look like this. Decreasing, increasing, decreasing. Decreasing, increasing, decreasing. So this does make sense. So then we just summarize it. Where is it increasing? Where is it decreasing? All right, it's increasing between 0 and 2, and we include 0 and we include 2. Where is it decreasing? Always start at -infinity from the far left all the way up to 0. We union that with 2 to infinity. So it's decreasing from -infinity to 0, and then from 2 to infinity. So you can kind of do a little sketch just to kind of help you visualize it better, but this is our final answer. Okay. All right, letter B, same thing. Start with the derivative. Set the derivative equal to 0. GCF set each one equal to 0. Create your number line and go in order. Okay, so let's pick -1. If I plug, do you see no matter what number I pick in here, that's going to be a positive number? And then when I put -1 in here, I have a positive times a negative, so that's negative. If I pick a positive 1, always positive, 1 minus 2 is negative, it's still negative. And then 3 is positive, positive, positive. So to me, let's superimpose our graph. Let's kind of look what this is saying. It's decreasing, 0 slope, decreasing, 0 slope, increasing. And does this kind of look like an x to the 4th graph? So f prime is negative or positive, and f is decreasing, decreasing, increasing. All right, so it's decreasing from -infinity up to 2, including 2. Then it's increasing from 2 to infinity. So think about if I would have asked you to graph this, you would have had no idea what it looks like. The derivatives help us to see kind of what's going on with the graph. Okay, so this last one is a little bit tricky, so just be patient. So whenever they give us a show that, this is where when you take your derivative, you have to manipulate it to match theirs. So we're going to start the same way we always do. And I kind of put my derivative up above it. I guess we don't need to, but kind of save some space because we're going to probably need quite a bit of the space. All right, so f prime, the first thing I want you to make sure you notice, quotient rule because it's a fraction. So we just square the bottom, then the bottom, times the derivative of the top, minus the top times the derivative of the bottom. So we're going to have to be really careful here because we have to distribute this and subtract the answer. So be careful. All right, the first thing I want you to notice, their bottom looks different than ours. Why? Well, if you factor this, the inside is x and x, factors of 3 that subtract to get 2, plus 3 minus 1. So when they squared it, rather than squaring the whole original one, they just squared each one, which means it's just x plus 3 squared times x minus 1 squared. And the order that you write, that's not that big of a deal. All right, now we have to distribute our top. So take 2 times everything. Now, I'm going to put a parenthesis here because we're going to have to distribute this later. So first I just want to multiply my 2 parentheses. And then I need to distribute that negative so I can combine my like terms. So 2x negative, or 2x squared negative 4x squared negative 2x squared, 4x minus 4x plus 6x, negative 6, positive 6, that's my numerator. Keeping the denominator, and if you want to rewrite it so that it's in the order that they have it up here, that's fine. I don't think that would really matter. Now, what's different about our numerator and theirs, we just need to factor out the GCF. They factored out the negative 2. Then we're left with x minus 3 and carry over the bottom. Okay, now we're going to do our sign chart. So sometimes I think it's helpful. We're looking for 2 things when we have a great big fraction like this. Anything, let's think about 0 and fractions. We can take 0 divided by anything, that just equals 0. But if we take something divided by 0, that does not exist. We can't, that's an error. We can't divide by 0. We can take 0 divided by something, but we can't divide by 0. So anytime you see a fraction like this, the numerator is what makes f prime equal 0. So we need to look for what makes the numerator 0. That's going to be x equals 0. What makes this 0? X equals 3. Then we need to find out what makes the derivative not exist. That's what makes the denominator 0. When x equals 1, x equals negative 3. We're almost there. All right, so on my number line, I am going to differentiate using a dotted line and a solid line between my equals 0 and my does not exist. So if I go in order, I need negative 3 then 0, then 1, then 3. So -3 is a does not exist, so I'm going to do like a dotted line, because this is going to be a cannot equal. 0 is a solid line, that's just where it equals 0. 3 is a solid line, 1 is a does not exist. So for does not exist, use a dotted, and for 0, use a solid. Okay? All right, so now we're going to plug in points. So I'd pick -4. Now, my bottom is all squared. Denominator will always be positive. If I plug -4 in, that's a positive times a negative. So this will always be negative. Now let's pick, I'm going to pick -1, even though it doesn't matter. And remember, the bottom is always positive, so I don't need to really worry about that. So negative times a negative, that's a positive, and that's a negative, so it is still negative. Now we're going to pick a -1, or a +1, sorry. -2 times 1 is a negative. 1 minus 3 is a negative, so this is going to be a positive. Then we're going to pick 2. Negative, negative, still positive. Then pick 4. Negative, positive is a negative. All right. So it's decreasing, but then there's some type of an asymptote or something. Then it's still decreasing, increasing, increasing, decreasing. So here's where we use the dotted line or solid line for the increasing and decreasing. So my increasing is 0 to 3, but because there's a dotted in between, I cannot include 1. How did I, oh, I couldn't use 1 here. I had to use a half or something. Okay. So we're going to go including 0 because it's a solid line, not including 1 because it's a dotted line, union with 1 to 3, including 3. Okay. Now, decreasing is way at the left, so we start with -infinity to -3. -3 is a dotted line, so we don't include it. Union with not including 3 to 0, including 0. Union with the last one is including 3 to positive infinity.